Welcome to this topic video on JavaScript Async and Await. You should have already watched the JavaScript Promises video. Okay, so our objectives here are to understand what asynchronous functions are in JavaScript and the await keyword. Okay, then, we also want to understand how these relate to JavaScript promises. Okay. Then we want to make sure we know how to use async and await style programming, particularly to simplify ordered asynchronous operations. Okay, so those are things like that take a while, like a call to a database, a call across the network, that we may have to do in order. Okay, so let's get into this. References and readings. Okay, first of all, in the example code that I have all my async examples are the async and await examples you'll see in here. This is a good reference. I recommend it highly. Making asynchronous programming easier with async and await. That's from MDN. Another independent source telling you why async and await is better than plain promises for ordered operations, I would say. Okay, and the references on the async function and the the await keyword. Okay, those are our references. So, an asynchronous function is a function which operates asynchronously via the event loop, using an implicit promise to return its result. Okay, what do you mean by that, Professor? Okay, so here we're going to define two functions. One's called square. It returns the square of two numbers. The other's async function, a square. So as usual, just run these right in your browser. Okay, let's go to the console. Let's get rid of those warning messages and paste. We've just declared two functions, square, and a square. Okay. Now, let's take a look about using them. Okay, so let's go square 8. Yeah, Professor, that's what the square of 8 is, 64. Okay. A square 9. What? It's a promise? Oh. A square 9 dot then the result, we'll use an arrow function, goes to console dot log result. And let's run it. Woohoo! Okay. So an asynchronous function, no matter what you declare it async, it's going to return a promise. Okay. Okay. So why bother? Okay. It's great we can have make something return a promise no matter what, but why would we ever want to do that? Because we're going to get this new operator, await. Okay. The await operator is used to wait for a promise. We can wait for a promise. Well, we're always waiting. Oh, we're going to be able to wait for them right in our code in a specific place. So the syntax we're going to see that we're allowed to use only in an asynchronous function is return value if we want to keep it, await expression. Okay, where the expression is a promise or a plain value. Okay, and RV is the return value. Yes, if you're a mathematician or a statistician, RV always means random variable to you, but no, in this case it means return value. I kept wondering, why do I have a random variable here? It's not. It's return value. So let's try this, okay? So we've got the square function and the async function. We're going to define those. Now we're going to have this function async function test, okay? New promise. This is just to check out promises. Then we're going to say let x equals await square, y equals await square, console log. Oh, this is one of those tests where we see what happens in which order. Okay. So let's try this out. Okay. So notice we declare this async function. Okay. Async functions will return a promise. Okay. We call that async function, but we don't do anything with the promise per se. We don't necessarily have to. Okay. But inside this function, we're going to create another promise that resolves after a second. Okay, then we're going to call await here on these two different things. Okay, then we're going to do some computation, print those things out. Okay, oh, then we're going to await on the promise. Okay, and then we're going to print out the message. Ooh. Nice looking code from the point of view of doing things in order. So let's make a copy. Let's clear that stuff out. Let's paste it. Okay, and let's see. Okay, I gotta get rid of that. Okay, at this point, we have the function square, the asynchronous function a square, and the async function test. Okay, so nothing's running yet. So now we're going to run it. Okay, and we're going to first call starting test at this time. Then we're going to call test. Then we're going to call finish calling test. Okay, let's see what happens. Oh, what did it do? It started calling test at that time. Then it called finished. Oh, because this is an asynchronous function, it involves promises. Anything that involves promises is a trip through the event loop. Hence, even if we had something that was going to resolve right away, okay, everything gets put through the event loop, okay, because especially we have a promise, okay. But look, we got x and we got y, okay. It's two different values. And then, let's see, we got a message. Okay, so we got ran this. Then we got a message from this other promise that resolved, and everything happened in nice order. Or the order that we intended, or the order we were waiting on things, right? Look here. X await, well, that shouldn't do anything because it's not returning a promise. Here, we're waiting on a square, then we're waiting on the promise, okay? Even if we change the order of these things, that would be a good thing to do for you to try, you should still see that the order in which you say await and await, okay, should be the order things happen, okay? Oh, let's copy this again and do that ourselves to see that happen. Okay, so we're not going to run it yet because we're going to get. Now we'll leave that there for a sec. Okay, so what I meant to do, okay, was do this. Okay, take this line. Okay. Whoops, that didn't work. Sorry about that. Copy and paste don't work quite. Okay, try it again. Okay, so what I want to do is take this line to await the promise. I'm going to just get, okay. I'll take both of these lines, okay. Okay, so I'm going to take both these lines, the message line and the let line, take those, and we're going to move them right up here. So what we want to see, this has the delay of a second in it. So what we want to see is, will we get this message out before we see something come out here? Okay, so let's try this now. I'm going to hit the run button. I'm going to go back to our regular console view so we can see everything. Okay. Okay, what happened here? So we got high class printing out, then we got the x equals y. Okay, so we're able to force the order, okay, because we had a promise and we waited for it right here. Okay. However, async and await, like all promise code, is non-blocking. Okay, so that's example 1. Okay, try that. Okay. Ordered time-consuming operations are much easier to think about in a program with async and await. We just saw that. What happens if something gets rejected? Okay, so notice similar looking setup, square, a square, test function, promise, but this case I'm going to have the promise reject. Okay, and here I'm going to wait for the promise. Okay, so try out these examples. Control Shift, figure it out. Okay, we're going to call this stuff. Ooh, uncaught in promise, surprise class. Uncaught. Oh, what's going on there? Uncaught. What can't we catch? What didn't we catch? Oh, I bet it's an exception. Okay. Rejection in async await programming goes to an exception. Whoa, so that's going to mean that we can use our typical exception handling code. Look at this. Try and catch. Okay. If this promise that we're waiting for, where is it? Where is it? Right here. If this promise we're waiting for is rejected, it will throw an exception and come through the catch portion of the try and catch block. Okay. So that's very nice for error handling. Okay. We're back to exceptions and things like that. Okay. So let's try this. Okay. Using the try catch block. Okay. Once again, we're going to have this. We're creating a fake our own promise. It's a real promise. It's just not terribly useful for anything. Okay. We're going to have our own promise and we're having it just reject. Okay. We're going to wait for that promise down here. Okay. It's going to reject, which is going to cause a throw. Okay. An exception to be thrown. Okay. So let's copy this stuff. Clean up our messy here. Paste that stuff in there. Once again, try these examples. Okay, 1 1000, 2 1000, exception surprise class. What did I do? I caught the exception. Okay, and that was the message I said for this. Okay, surprise class, the reject path we took. Okay, so that's very nice. Okay, so inside async functions, when we use async and await, especially when we use await, we can deal with promise rejection via the usual try and catch exception handling mechanisms. Okay, let's see a couple more examples. Okay, remember way back when we first started studying some of this stuff, we had a silly clock. Okay, and we showed how to make a silly clock, a thing that could count. Our first attempt with callbacks didn't work at all. Then we had to nest our callbacks, and we said, ooh, that's ugly code. Then we came up with a promise version. Okay, a promise version that looked fairly simple. We have a function here that returns a promise that resolves. And then what we did was we had this function keeps returning a promise that resolves in 1 second. Okay. Sorry. This function here, elapsed time, okay, does my little counting, okay, then returns this 1 second promise, okay. So it returns something. We said if things return, we want to return stuff, it will be returning these promises, then we can vend them, we don't have to keep nesting. Just take a look, okay. I'm not saying that's the cleanest looking, easiest to read code or anything. Let's run it though and see if it counts. 1, 2, 3. Okay, so it does count. Okay. Now, we both agree, we all agree, you and me, that that's not the easiest to read code. Let's modify it with async and await. Okay. So I'm going to still use this function 1 second. Okay. What is it going to do? It returns a promise that resolves after a second. Okay. Then I'm going to have this little function advance time. Okay. He doesn't return any promises or anything. Okay. All he does is increment my time variable and check, does a printout, comparing my little time variable that I'm keeping track of with the elapsed time. We went over before how that happens. Okay. Now, oh, that's it? I'm going to say async function, my timer. I'm going to give it a, ooh, this is a variable number of things. Okay. Really, I can await in the middle of a loop? Let's see if this will work. Okay, copy it. That looks so easy. We can put an await in a for loop? No way. Really? Okay. I'm off. Okay, so we have this thing that creates a 1 second promise, okay, and we wait on that 1 second promise, then we advance time. Then we go around the loop. We create a new 1 second promise that we await on. Notice I'm not doing anything with the value, okay. Let's see if we can count to, ooh, let's change this value, 6. Okay, change this to any number you like. Will it work? 2, 3, 4, 5, 6. Much easier to read code? I think so. Yeah, there's still a promise in there. Okay. But it's only in one place. We're not even returning promises. Okay, yeah, okay. We have this one function that creates a promise and returns it. But from then on, things look like we'd like. Okay. The key thing to remember, though, is when we're waiting and awaiting on something, it's not blocking. This is still just promises underneath, okay, and with nicer syntax to work it, but we are not stalling out the browser. Other things can happen, okay? So that's kind of the key part, okay? We all started from callback events in the event loop with callbacks. We made a nicer programming paradigm with promises built on that. And this takes it one step further. Build on top of promises is this async and await. Okay. One thing to notice, okay, this function returns promises and knows how to deal with the event loop. The reason why is we put the async keyword. Okay. That's some overhead to do that. Normal functions cannot have an await in them. Okay. They're not set up to do that. We have to tell it that we want an async function and that we're going to do something asynchronous, most likely, otherwise it's not worth the bother. Okay? So this sets up the mechanisms for being able to deal with promises and stuff here. Okay? It's like we're able to jump back into this code, okay, after this time expires and advance. Okay? Wherever we go otherwise, that's okay. Okay. Now, can you think of a cool example that you might want to do, that you could do with this to show? Maybe start 2 timers, one for every 2 seconds, one for on the odd seconds, one's on the even seconds, and have it print out 2 different things from 2 different things happening. I think we'll make that into an interesting homework assignment. All right. Okay. So getting more out of this and showing the asynchronous nature. Okay. What about web requests in order? Okay. Back when we were learning how to do some requests, we had different sites. We wanted to go visit those sites in order. We used the fetch call. Okay. I'm using this from Node so we avoid having to worry about cores, this cross-origin requests stuff. Okay. So we're doing this in Node, so we're using this library node fetch. We have 3 different sites. I want to visit them in order. The first site is my site. The next site's Google. The third site was Kite West, Australia. Okay, so we looked at this code. We can't run this code in the browser, but we can run it over here. Okay, so node read in order.js. Ooh, what's the delay? 3 in order. Kiteboarding, Australian kiteboarding came back. Let's just run this again. Why is it so much quicker the second time? It's not because the internet got quicker. It's the first time we went through, we had to go actually look up and ask this thing for the DNS because I don't visit this site very often. So it had to do a DNS request. To go get the details about this, it ended up having to go talk to a DNS service all the way over in Australia. Okay. Afterwards, after we've done it once, it's going to keep that DNS entry cached. Okay. So that's why the true delay, okay, between Google after this car from here to here, it's a half a second or so. Okay. It's not 3 seconds. Okay. Now, what if we want to do the same thing with async and await? As you might guess, the code's going to look nicer. We still have our setup. We got our URL and we have the specified options. We have to put things in an async function and then call that function. So let's look at this up close. Okay. 3 in order async. I just find my sites here. Okay, to use the fetch. Okay, I say site and I give the URL. I just kept all my sites and the information all together there. Didn't necessarily have to do this, but I was updating my code from a previous request library I was using on the Node side. Okay. So what are we saying? Get the response. Oh, we await the response from the fetch. Okay, and we record the time. Oh, we just await, and this thing gets filled with the response. We say fetch, await fetch, this thing becomes the response. Oh, the code runs in order. Why? Because we're using await. We're telling it to wait for this response. Okay, it's not blocking though. Okay, we could launch, you could try it, another function here after this one that will do things over time, okay? And it'll look like they're running all in parallel because they're not blocking, okay? If you really want to force and block it, which, okay, the way you have to do that is, the rule was we run to completion, okay, in our callback functions. Okay, so if we have an operation that takes a super long time to do in a function, that gives us blocking-like behavior. This will not. It'll wait for this. It waits virtually for this to come back. It's a promise-based, okay? So it's like it jumps back here after it's done. All these calls get made, and then it jumps back in order the way it needs to do things, Okay, interesting. But it looks like when you read the code that I'm waiting here, then I wait here, then I wait here. But it's not blocking. Okay, it's still a more simplified uh, thing than dealing with threads and such like that, but it's very, very useful. Okay. Before we go to this complicated example, where might you need to do this on the server side? Okay. A lot of times we need to call databases, okay, or file servers. We said that Node is very good about all its file system requests and all its networking requests, okay? And we can, any existing callback node interface we saw, we could turn into a promise interface. If we've got a promise interface, we can await it, okay? So if I have to go and look up things like in databases or go from the file system and do things in a particular order, okay, so let's say I have to look up a user in a user database, and I get that information, then I get information from another database about whatever the user is trying to store, things like that. Yeah, got to do those things in order. I love async and await for that. It makes the code read just like you'd like it to happen, but it doesn't block. Okay, there's no blocking. Okay, it's kind of a nifty thing. Okay, now let's look at a complicated case. Okay, here's my example. Okay, we're collecting sailing logs from a website such as www.windsurfgrottonetworking.com data logs. What does that look like? Windsurf logs. Okay, so here's my log years. Go to 2019. We see there's a bunch of records, okay, about various windsurf journeys, okay. And if we click on it, we can see GPS tracks and things like that. We're interested in going back and collecting information about these windsurf journeys, okay. Each one of these things is a record. This stuff is actually stored in JSON format, okay? And there's 11 years of logs from 2009 to 2020. Each log has between 40 and 80 samples. Each one of these is a windsurf or kite surfing session, okay? We want to start with the current year and go back in time until we have enough samples to do some statistics. We don't know how many files we're going to need to recover ahead of time. Okay, so that's the idea. We've got an undetermined amount of data collection. We're going to just keep going back in time until we get, say, 200 samples. Okay, because we're trying to, and maybe we'll go again for 300 samples to see the statistics and how they work out. Okay. I found this hard to figure out how to do this with promises, okay? What I ended up with is something rather ugly. I used recursion and side effects. I declared a couple global variables like total count. I had my current year, okay? Then I got into this function that just started doing all sorts of things, and I used binds, and I recursion, total count, then log add. See, we're calling ourselves again with the new year data and stuff like that. Then I launch that thing. The code is not terribly long, but you read this and see if it makes sense to you. Okay, I found it hard to come up with and hard to write. Your challenge, come up with a clean, non-recursive promise-based implementation if you like. Let's look at the async and await version. Okay. So here's my desired count. We can change this thing as ever we please. I have an async function get them. What's it going to do? Total count. Current year equals year, the starting year. Oh, well, total count is less than desired count. I got the URL. I go total count plus equals await, fetch the thing. Then we do a then, and a then for the data length. Wow, one item, we just add that thing together. This is going to get how many entries? Really? Let's go look at that code. Let's go run that code. Okay. It just is, it's just a while loop. Okay, saline count. Okay. While total count is less than this. Fetch the stuff. Look at how many records were in it. Add that together. Okay. And here we decrement the current year so we can go back in time if we need to. We go around the loop. That makes sense. That's the way we think about doing it. Okay, let's try running it. Okay, node saline count dot JS. Wow, easy peasy. Well, as easy as going and getting an indeterminate amount of data could be. Okay, so we can change this number. This loop will still function, and it's a simple loop that we're going to start at 0. Then every time we go get some more records, we find out how many records were in that data, and we just add it to the current count. And if need be, we go get another year. Okay, and we print out things as we go. Notice, once again, async functions return promises. We're not using that here because this is the highest level of stuff. Okay, so there's nobody who's going to take that promise return to do anything with it. Okay, but this was yet another case, okay, where I want to do things in order. Async and await makes the programming just so much easier. Okay, so to summarize, async and await doesn't replace promises. It uses promises. Okay, I find async and await much easier for things that you want to do in a specified order. Okay, you want to do things serially, one at a time, or something of that effect. Okay, you can combine async and await and promises. Okay, like promise all and promise race. Okay, remember that promises and async and await are mechanisms for asynchronous programming provided by JavaScript. Other languages and environments may have more or less mechanisms to support this kind of thing. Okay, so right now this is a JavaScript kind of thing. Python's getting something-ish similar. Node and the browser both implement these things. Okay, that if you're doing a server in Node, you can use this. You'll want to use this. And in the browser, okay, if you're doing more complicated calls, you don't need async and await if you're dealing with a single promise. If we're doing a single fetch thing, we don't need async and await. If we're going to do a couple things that we have to have it done in a particular order, then I probably would, because the code's just so much clearer. Okay, I mean, chaining a couple promises versus, but see how the code looks. Okay, but once things get a little bit more complicated, I just really like the async and await. All right, go use it.